Right. Let's see. There we go. Welcome back. Yes. Or welcome if you haven't seen one of these yet. Just have everything set up here. There we go. Right. Advent of Code, day 4. As you can see, I put day 3 up after yesterday's stream. Try to not sort of show my login thing on screen. Yeah. So again, for people who don't know what's going on, we're doing Advent of Code live. I haven't looked at them. I haven't looked in the chat at any of the solutions that people post or anything. We're just gonna go in blind and see if we can sort this one out. We're doing the solutions in Nim as usual. So yeah. Day 4. Scratch boards. Your gondola takes you up. Oh right, yeah. So last time we fixed the gondola, managed to get the gears right, and now we're heading up to the source of the water. Was that where we were going? The gondola takes you up. Strangely, though, the ground doesn't seem to be coming with you. Wait, what? You're not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. So it's like 2 floating islands connected by a gondola. That's cool. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Oh, hello! The elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure. I just operate the gondola lift. Well, I'm not gonna do accents here. That does sound like something we'd have though. This is Island after all. I bet the gardener would know. He's on a different island though. The small kind surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat and you can go visit the gardener. I got all these scratch cards. What is a scratch card? As a gift, but I can't figure out what I've won. Oh, like a scratch ticket? Right, yep. This one appears to be Christmas themed. Right. The elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Oh, so he's gonna have all the fun. Picking one up, it looks like each card has 2 lists of numbers, separated by a vertical bar. A list of winning numbers, and then a list of numbers you have. You organize the information into a table, which is our puzzle input. Right, so each card, these are the winning numbers, these are the numbers that we scratched off, I guess. As far as the elf has been able to figure out, you have to figure out which of the numbers you have, the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point value of that card. So in this case, we have 48 here. We have this one there. And so that's 1. and then we have 83, which makes it worth 2, and then we have 86, making it worth 4, and 17, making it worth 8. So this card is worth 8. In the above example, card 1 has five winning numbers, and 8 numbers you have. Of the numbers you have, 4 of them are winning numbers. That means that card 1 is worth 8 points. 1 for the first match, then doubled 3 times for each of the 3 matches after the first. Card 2 has 2 winning numbers, 32 and 61, so it is worth 2 points. Card 3 has 2 winning numbers, 1 and 21, so it's worth 2 points. So on and so forth. So in this example, the elf's pile of scratch cards is worth 13 points. Take a seat in the large pile of colorful cards. How many points are they worth in total? Right, so let's grab this as our puzzle input. New sample input. So this is just the input from the example. I like to start with this one so that we can sort of check our solution on the part that is explained already in the input. And let's have a look. So what I'm thinking, we can turn these two into sets. Then we can do a set operation on them. Get the cardinality of the set and use that to calculate the value, which is one way of doing this. I guess we could use NPEG for this. I mean, we don't. It's a bit overkill. We don't really have to. But I talked about NPEG in the two previous streams now, and I feel we should show how this works. So NPEG, for those of you who haven't seen the two other, or my other streams, is a parsing library that takes a domain-specific language. It's a macro, and it rewrites this as a parser. So for Nimble packages, so this package is in Nimble. Nimble is a package manager for Nim, which just has a list of packages. So we can just run Nimble install NPEG. Downloading. Right. So I already have the latest version of NPEG installed. That's great. We can then just import NPEG. And each of our cards. So the way NPEG works is that you use this peg macro. You tell it which rule it should start from, and then you give it the result type. What is this going to return? So let's first define a type for our card. So one card, it has an ID or a number. So card 1, card 2, card 3. And then it has winning numbers, which is a set of uint 8. Let us actually just check real quick. So all of these are well within the uint 8 255 limit. So let's have a look at the real puzzle input. Yeah, they seem all to be below 100. So actually let's do the set of numbers from 0 all the way to 99. I guess 0 is probably not in here. Yeah, 0 is not in here, but 1 is. So we can do a set of numbers from 1 to 99, and then our numbers is a similar set. And then we can say that we want to create a parser and invoke the peg macro. So let our parser be equals to peg, And we're gonna start this out with just a rule called card, I guess. And it returns a, okay, so the rule called cards, it returns an object called, or a type called cards, which is a sequence of our card objects. Right? So our cards rule. So these are rules, and rules can have, or I guess they're not called rules in this. But yeah, so let's call them rules. So here he says that pairs is a pair followed by 0 or more of this thing, followed by nothing more. So what we want to do, we want to say that a card is a, or cards is the rule card, followed by, and card here is highlighted because it's the cardinality of a set. That shouldn't matter. Is a card followed by a new line, and we want to have one or more of these cards. All right, that should work, I believe. So then our rule for a card, and here we have to look at what our cards look like. It's a card with capital C, then a number, then, or card with a capital C, space, a number, then a colon. So let's start with card, space, followed by, or actually let's do, I guess the bigger input is probably, yeah, it's formatted with more than one space so that these colons are aligned. Let's do card followed by one or more space characters. So star is 0 or more, and the followed by character, which is a bit confusing. Plus one or more. You might recognize this if you've written a regex thing. Is my stream quality okay, by the way? It looks all right in OBS, but when I looked at it on Twitch, it was kind of crummy. I guess it's maybe just my internet that, yeah, stream is okay. Okay. I guess it's just that streaming up and down maybe it didn't like. My connection should be good enough. It's I'm hardwired into a fiber connection. So yeah, this, and then 0 or more digits. So, oops, digit. If you look at the MPEG documentation, it has, yeah, so the syntax, and then in addition to this syntax, it also provides a couple of built-in shortcuts. So one of the shortcuts is digit, which is just all the digits. And here we can see all of the operators. As I said, plus matches P 1 or more times, star matches P 0 or more times. So we're going to do here card and at least one space, but more is also okay, followed by more than one digit, and then followed by a colon. And we're going to say here, so we have made a field here in our card for the ID. So we want to capture this string of digits. And in NPEG, you do that with the right arrow captures the string matching P. So in this case, yeah, so here, for example, it catches a word. Here it catches a number, and a number here is plus digit. So I guess we could do that as well. Let's say capture a number, and we create another rule for number, which is just one or more digits. So we capture a number, and then what more is our input? So we have captured this number, then the colon, and then this is a list of numbers. So followed by a number list, and a number list is 0 or more space characters. So this colon here is the last thing on our line, so it's here, followed by any number of spaces, and then a number. So any number of spaces followed by a number. Of course, we need to capture that number, but we also want more than one of these. So we say plus. So plus all of this. So at least one or more of this group, which is 0 or more spaces followed by a number. And then that will sort of error out when it comes to this, and this would be the last parsed character, so we'll be standing here. So back up here we say followed by one or more spaces, followed by, well, I guess in this case it's always one space and a pipe, and it's one space and a pipe, and then maybe more than one space. But we can say number list followed by space, pipe, space, followed by another number list, which is going to be this list. And then it stops when it comes to the end of the line. That is where the card rule ends parsing, because it's no longer able to do this, and that goes to the new line, and that carries on. So now this should match our input. If we just do this, discard, and we have a capture here as well, so just discard. I'm not sure we need discards there, actually. I think this should work. So if we go here, we can see we have now created a parser, and now we do parser.match. It needs to take a var of our type in. So we can echo out, or first let's create our cards, which is a sequence of card, and then we echo out parser, which is the name that we gave our parser, match the string in the sample input.txt file, put the results into cards, and that should give us something out. So if we now run this, we will see that parsing OK is true. It managed to match our string. Match length was 294 characters. If we have a look at our sample input, pipe that into vc-c to count the amount of characters in the file, 294 characters. And then it has this cs, which is captures. So at the moment, we have this data structure of just captures. Okay, apparently that doesn't have a good echo function. But we will see that we don't have anything in our cards. Our sequence of cards is empty because we never add anything to our sequence of cards. And that is where capturing comes in. So in here, we can't, right. We might have to do this actually, like that. So this rule now has 3 captures. It has the number, it has the number list, and it has another number list. So we can now say echo, and that uses this syntax. So $1 is the first thing that it matched. So in this case, it would be this one. $2 is the second thing that was captured. $0 is just the entire line or the entire rule. So if we echo out $1 here, and we echo out $2, and we echo out $3, we will see when we run this that we get the number 1 and this sequence of numbers, and then this sequence of numbers, and then card number 2, this, and this. So that all looks good. I don't remember what happens if we do. Yeah, we don't get a type out of this. That is one of the things that I seem to remember that I didn't like in NPEG, that we were not able to sort of pass, to sort of build types in a simple way. We can't have a number list here that we sort of build, which will be available here as the capture. I don't think, anyways. It didn't used to be able to do that. It's been a while since I've used MPEG, but I did have the latest version installed, which is an indicator that it still doesn't support this. Yeah, I don't think it does. So the way that you can do this, if we had done this instead, we can now echo out $1. So what we will see here, yeah, it prints out 41, and then so the first number here, and then 83, which is this, the first number there. It doesn't even print out all of them, which is a bit disappointing. So yeah, we will have to go with this one. So here we have defined that this parser will have available a type called cards, which is the result type. So we can say cards. Well, actually, let's first create a new card, like this, and that card, the ID of this card will be the integer from our first match, so this number right here, and then the card winning numbers will be this, but we need to do a little bit of stuff with this. We're going to strip this for white space, and then we're going to split this on the space, on space characters, and Actually, I think just split some white space, so that should be fine. And then we need to turn this into a set. I'm not sure that works. Okay, that, oh, maybe not. Let's run this. Our undeclared, oh, we of course need to import our str-utils to get parse int and split and all the others. But yeah, toSet doesn't exist. Do we have a set utils? I believe we do. And I believe it has some toSet and iterator. Yes, this looks good. toSet, that is great. So we need to import in here also a set utils like that. It still doesn't seem happy. Ordinal type expected, of course. We call toSet sets the default set type, so the built-in oh, not this one. The built-in set type, and this is a bit confusing. Nim has a built-in set type, which is the one we're using here. It's a super easy type. It's just a bunch of bits. So you give it a range. It can't be larger than a uint16. But as we saw, we can also give it a range. Basically, what happens when we say this, it will allocate something with, in this case, 99 bits. And it will just set the bits according to what we have in our set. So this is the built-in set. We also have sets. The module in the standard library called sets, which is not the built-in sets. These are hash sets. So a hash set, kind of a similar thing to a hash table. They hash the key that we try to put in there, and they're a bit different. We also have int sets, which is just an optimization for sparse sets of integers. But in this case, we're talking about the built-in set type, and it can only do uint16. You call them small s set and big S set to differentiate. I tend to think of them as set and hash set. I would kind of have wanted the module for sets to be called hash sets instead of just sets. I think that would have made it a bit more obvious. But yeah, so of course, this ends up giving us a sequence of strings, which toSet doesn't know what to do with. So here we do this. Actually, I think we can do map here. Map parse int over all these strings of numbers, and then we turn that into a set. Let's see. Map, of course, is from the secutils package. So we have secutils, and then we run this. And I'm getting something nice and warm here. It looks like, isn't that? I get handed you can see that, a very nice snowman mug of what we call glug, which is not sure what you would translate that. It's like mulled wine, but it's not wine. It's just spices. It's very good. Set is too large. What? Oh, right. So here we are creating integers, but integers, we can't create a set of integers. So we are actually too large for a set here. So we're going to do this, parse int, and then we're going to say we want to have this in the range 1 to 99. If it gets anything else, throw a runtime error. Got int for parse int, but expected range. Okay. Range 0.99. Does this work? There we go. Okay. So yeah, we parse the string into an integer, and then we cast or we convert that integer into a range of 1 to 99. If this fails, it will fail here at runtime, and then we create a set out of that. And we do basically the same thing with our numbers, because that's the same thing. By this point, we could probably have just done it manually. Value error, invalid integer, that's a space, it appears, or it looks like. Let me have a look at this. Right. I think maybe it is splitting these into two. So let's just do this part and see what the sequence looks like. Yes. It splits those double spaces up into an empty string, which is of course not what we want. There is something in the stereo utils for this. Let's see. I think it is in the split. Max split. Is it split white space? I believe it is. Yeah, this appears to do more than one split white space. So the default for split is to split on white space. Yeah, that looks better. And we should do that up here as well. We just got lucky. There we go. And if we now add our card to cards, we will see that, so the parser returns OK is true, the match length and the match max and all that from before. But now our array of cards is full of cards. Properly good, nice, nice actual nim types, all properly well and done, which are nice and easy to work with. Of course, here we create the card value or the card object, and we add that at the end. I'm a bit partial, like I would typically do this. And let's do this instead. Like so. Use an object initializer instead of creating an object and assigning fields. Just a little bit harder to forget to add it to our set. Ooh, but it did not like that because we do not have commas here. There we go. That's better. Nice. Okay, so let's just change this to an assert on the OK field. So it will just throw an error if this is not okay. So if we're down here, we know that cards is full of these cards. So what was our task? Yeah, so we need to find the winning numbers. 5 winning numbers ends up with the value 8. So let's kind of looks more idiomatic. Yeah, this I like doing it this way. I also am partial to putting this on that line. I mean, we already have the commas on these lines, and it just saves us a line. We're not a bracket language anyways. I would have kind of wanted a syntax like that or something, but alas. Well, let's just say that winning is cards dot so for card in cards, we need our sum, of course, or our score, I guess, starts at 0. So for each card, the winning set is the card winning numbers intersected with the card's R numbers, so the numbers that are R's on the card. If we echo out winning for each card, we should now see that we get, so these 4. Oh, right, yeah. Yeah, it has 5 winning numbers, 8 numbers that we have. Of the numbers you have, 4 of them are winning numbers. Yeah. Card 2 has 2, card 3 has 2, card 4 has 1, and none for 5 and 6. That looks all right. Of course, we don't really care about the numbers. We care about the cardinality. Yeah, star here is intersection. If you have a look again at the nim set, built-in sets, which we can go to from here. Here we have the operations that are supported by sets. Let's zoom in a bit. So yeah, we can have the union of 2 sets, which is a plus, the intersection, which is a star, the difference, and of course equality and subset relations and all of that, and the cardinality, which is basically the length. So we can do this, cardinality. So how many winning numbers are on our card? 4, 2, 2, 1, 0. And that leads to a score. If winning is greater than 0, otherwise the score is 0. If winning is larger than 0, then it's 2 to the power of winning minus 1, I believe it would be. And power comes from the math module. And we need to put that in quotes for this to work. I'm sorry, what now? Oh, the power function takes two floats, and we gave it an int literal, which it is able to convert into a float, but this integer it's not able to convert into a float. If we just say that this winning number is a float, then it should be happy. And here we go, 822,100, which is so yeah, 8 points for the first one, 22100. That should be fine. Then we just say that score is this. Just convert that back to an integer because we don't really need it as floats. And then we can echo out the score at the bottom there. And there we go. 13 is the score from that. 13 is indeed the score that we expected. If I now take my puzzle input and store that in our day 4 folder alongside the sample input, I can now say switch over to the real input format. Oops, what on earth was that? The format is indeed the same, so the parser should still work just fine. We run through this, it spits out a number which should be our correct score. That's the right answer. You're 1 gold star closer to restoring snow operations. So, as you can see, we spent quite a bit of time writing the parser, but when we have the parser, when we know that the parser is right, it's so easy to work on the result. You can see our business logic down here, 4 lines. So it's a really nice sort of split of like splitting the code into distinct sort of jobs. So this parser, the only thing it does, it takes in a string, it returns a sequence of cards, and it has this nice syntax. Of course, you need to get used to the syntax, but this is a great example of using macros for sort of creating something readable. If you know how to read the syntax here of pegs or npegs, it's really nice and readable. We just intersperse a bit of logic to get our numbers, or to get our results into this type we specified, and then the actual work is just super easy. So I'm hoping that we can now quite easily reuse this result for part 2 and not have to touch our parser at all. But that remains to be seen. I might be putting myself up for some disappointment here. Part 2. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. So you remember from part 1, he was just telling us what he thought the rules were. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards, equal to the number of winning numbers you have. Right. So equal to the number of winning numbers. Specifically, you win copies of the scratch cards below the winning card, equal to the number of matches. So if card 10 were to have 5 matching numbers, you would win 1 copy each of cards 11, 12, 13, 14, and 15. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. Wait, copies of scratch cards are scored like normal scratch cards and have the same card number. Oh, okay. As the card they copied. Wait, how do we get a copy? Okay, so if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won. Okay. 11, 12, 13, 14, and 15. So it wouldn't win. Wait, if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10. Yeah, obviously. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. Okay. So this time the above example goes differently. Card 1 has 4 matching numbers. So this is the same sample input as up here. Card 1 has 4 matching numbers, so you win 1 copy each of the next 4 cards. So we win 1 copy of each of these cards. Your original card 2 has 2 matching numbers, so we win an extra copy of 3 and 4. Your copy of card 2 also wins 1 copy each of cards 3 and 4. Your copy of card 2. Oh, right. So we have all of these originally. And then from the first one, we win a second copy of this card. Right. So then we get a copy of 3 and 4. Your copy of card 2 also wins 1 copy each of cards 3 and 4. Your 4 instances of card 3, 1 original and 3 copies, have 2 matching numbers. So you win 4 copies each of cards 4 and 5. Your 8 instances of card 4, 1 original and 7 copies. Wait. Right, so you win 4 copies each of 4 and 5. Your 8 instances of card 4, 1 original and 7 copies, have 1 matching number, so you win 8 copies of card 5. Your 14 instances of card 5, 1 original and 13 copies, have no matching numbers and win no more cards. Your 1 instance of card 6, which we had originally, has no matching numbers and wins no more cards. Once all of the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, 8 instances of card 4, 14 instances of card 5, and 1 instance of card 6. In total, this example pile of scratch card causes you to ultimately have 30 scratch cards. Process all of the original and copied scratch cards until no more scratch cards are won, including the original set of scratch cards. How many total scratch cards do you end up with? Oh boy. That's a horrible way to run a lottery. I mean, talk about people, yeah. Someone on YouTube asked me if I speak Hindi. No, I don't, unfortunately. I don't think I know a single word, not even like hello or thank you or anything like that. Right. So we need to set up some kind of count of how many cards this one. So we start, we have a, yeah, my model should still be good. Like the parsing, all of that is fine. So we set up so that we have a table, one of each. Then we figure out how many of these do we win, or how many from this do we win? We win these these four, sorry. So then when we come down to here, we now have 2 of this one. So we figure out what this card does. And then we do that, like we multiply that by 2. So I think we would want to set up, how many cards do we have in our, I don't really like doing this. Well, actually, don't do that. Yeah, so our cards, these are our total amount of cards. The only thing that we could do is sort of add our count here, like this. And we could just say that the count starts at 0. And sort of have our count baked into the object, which might be a nicer way to solve this specific problem, but I want to work with this as it is right here. I don't want to, basically I don't want to change anything above line 22. All of this should stay the same. Maybe we need another import, but well, we can add an import down here as well. So we won't change anything above line 22. That's the goal. So we need a count of cards. So counts is a new sequence of integers, which is the length of our cards. So if we run this part 2, we will see that we now just have a big old list of zeros. And we're going to, okay, so I lied. We're going to temporarily change this into our sample input. Yeah, so here we have our 6 cards, but now they all have a count of 0. We can do a new set width and say 1. That basically initializes this sequence of integers with the number 1. We can see that there. This is actually a statement. So we can do, like, if we had the random module imported, we could get like a random number. So it can run code in here as well. But we're just going to use 1 for this because we have 1 of each. And now we are going to, can I do a for loop? Yes, I can. Because we're only going to go through this once. So we need our same winning scheme or same winning count as before. Let me actually just copy that from here, like so. So we have our same sort of winning thing from before, but now let me not convert those to floats this time. I'm going to just keep them as integers. So when we encounter this 4, that should increase the count of all of this by the amount that this current card is at. So that means that for W for win in the range going from I, so our card, plus 1 to I plus winning. So if you win one card, it will go from the next one all the way to the same card. And we now have an index, and we say that the counts at that index increases by the count at the index that we're currently at, right? So at the end of this, actually let's echo this out for each number of the loop so that we can see what's going on, and let's echo it out at the end as well. Let's echo out I, so just the card number and the list that we have of cards. Right, I listed out the cards. I meant to list out the counts. Problematic in Las Vegas. You're a card counter now. Yeah, I guess. I mean, we're counting scratch cards. I think that should be fine. So yeah, here after parsing the first card, we have gotten a copy of one of each of these. After we parsed this one, we got a copy of these two. And of course, since we had 2 of these, we now have 4 of each of these. And that keeps adding up. And of course, what we want to end up with is counts. And then we can do what's called a fold L. As you can see, it's a template. It takes a sequence and an operation. I think this one is optional. Untype. Templates to fold the sequence from left to right, returning the accumulation. This version of fold L. Right, that's this version. But we just want to do A plus B. So take the 2 numbers so a fold is basically you apply one operation to either side of some sequence. You run an operation that returns 1 element instead of the 2, and you just keep on applying that until your sequence is a single value. If we run this, we can see that our final is 30, which is the amount of scratch cards that we wanted to end up with. Once all of the originals and copies are processed, you have 1 instance of card 1, 2 of card 2, 4 of card 3, 8, so 4, 8, 14, 14, and 1. So that is all well and good. We can now switch back my cheat. Our line 21, I said I wouldn't change anything above line 22. And now we can run this on our actual input, and we can see that we end up with actually quite a bit of scratch cards. Some of these numbers are pretty big. Oh, here we have some really, really big ones. But this is the number that we care about. How many total scratch cards did we end up with? 10 million scratch cards. And that's the right answer. 1 gold star closer to restoring snow operations. Right. That was Advent of Code, day 4. Let me make this a bit. Oops. Why is this? There we go. Let's not echo out this. That's a bit noisy. But yeah, as you can see, when we have a parser like this, it just makes it easier. Like I changed 4 lines into 6 lines to solve a completely different problem, and it's just a nice way to structure your code. Sort of first build nice nim types, and write a parser that does that job and only that job. And then when we get that output, we can do what we want with it in a nim, or in a much simpler way. Oh, we went for Go today. It was boring, but okay. Yeah. Try D. I haven't actually, I haven't looked that much at D. I looked at Sig a little bit. Rust, I checked out just briefly. Go, I actually did some Go back in university. As you say, it's a bit boring. It works. It's great for threading, if I remember correctly. But it's just not quite. I don't know. It's just a bit boring. It feels very dry. It feels very. I get paid to do this, so I'm not allowed to have fun. Yeah, the channel system is good. Multi-threading in Go, great multi-threading story. I hope that we can get there with Arc and shared memory across heaps. And it looks like maybe, but basically no one has just started poking at that too deep. So no one really knows how that is gonna go. But yeah, it should be possible to sort out. Oh yeah, and for this we didn't use math, so I'm even cheating. I'm removing one of my imports. I'm not quite sure what this is complaining about. I'm guessing. Template instantiation of some random template. Blah 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 blah. Yeah, the new sec is the problem. The range 1 to 99 int type doesn't have a valid default value. Oh, right. That's a new warning. It's an interesting warning. But it's a new warning. Basically what it's saying is that, so in nim, we have default values. As you can see here, I just say that this is a sequence of cards. It is the, like it defaults to an empty sequence of cards. And the way it does that is that it says, we can't have numbers. Or it just says all this memory is 0. So it just zeroes out the memory. And then when nim goes and tries to use the sequence, it sees that, oh, the allocated memory for this is 0 bytes long. And the pointer is a nil pointer. So I will allocate some memory for it and do what I need to do. And that works really well for almost all types. But a range from 1 to 99, the default value is still 0. It's still nulled out. And it doesn't, probably for like optimization reasons, it doesn't treat the number 0 as the 1. It doesn't like add on that 1. Which means that if I do var x is the type or has the type range 1 to 99. So I won't be able to say x is 200. This is a compile time error. It can't convert the number 200 to the range 1 to 99. But if I echo this out, we will see that this number is 0. Yeah. In this case, it would be perfectly reasonable to do this. To do that and to do this. That will, as you can see, as you can see now, the warning on this line is gone. So the warning there is now gone. So if you need for some reason to compile without warnings, you need to include a 0 in your ranges, unfortunately. Of course, just to show off another nim feature here, we can say we can do this. Num range is 0 to 99. And we can say that this is a set of num range. This is a set of num range. And just map this. And now we can even do the inline thing, I believe. Let's convert that to a num range. And convert this to a num range. And it will still do the exact same thing. We have just created now an alias for our type. So num range is just this range, and that just works. Again, of course, if we do the range I wanted to do, so apparently nim wasn't smart enough to see that would cause the same error, or does specific types like that have a sane default? Nope. Okay, so nim just wasn't able to statically figure out that this number was not did not have a sane default, or rather it didn't complain down here at least. So now we can compile without warnings and keep our range good. Of course, in this case, the only reason that we want to specify this range is for this set to be as small as possible. It would have the benefit, if I just open my actual input here, it has the benefit that if I have a number which is too large and I now try to run this, as you can see, it throws an exception, unhandled exception, a range defect, value out of range 136, not in 1.99. Not quite sure why that is a defect. That could have been just your bog standard catchable error. Yeah, so defects in nim, you can't catch a defect. Oh, you had a forum post about the range defect? It is catchable, but not in the way you think. So if I do this, and we say accept a range defect, we can say range defect and quit with the error code 1. If we now just introduce the range defect again, we can see that we can compile and range defect. It says execution of external program failed. That is just because I'm running with nym cr. If I'm just compiling the program and then running the program, you can see it just prints out range defect and it returns the number 1. Nym, when it runs a program, it looks at the error code of the program and it spits out this message if it's not 0. And that looks good. That's what we want. However, if we turn panics on, now it converts now it converts range defects into panics, and we can no longer catch it because this does not now propagate up the exception chain. It's an immediate panic. It just, when this occurs, it prints out the traceback. It stops your program. I think the idea was to make panics on the default. That defects were sort of the idea of a defect in nym is things that you can't recover from. So you can't recover from, for example, a memory allocation error. Maybe your program can, but in general you can't. Or you can't convert from, or you can't, there are certain classes of errors that you just shouldn't try to deal with. And that a bare, the bare accept clause would catch them and sort of hide. So if we didn't have range defect here, like try accept, if that caught memory allocation errors, we would get some really weird results from this code if it ran into that scenario. So basically nym sort of at some point split exceptions into catchable errors and defects. And for some reason, range errors was thrown into the defects category, which for parsing like this doesn't make any sense because we're parsing strings. This string, like I would want to be able to check for that. But now I would have to add a separate check to say, is this convertible to, like, is this number in the range? If it is, then convert it to the range. Otherwise, throw this exception. Let's see. Yeah, someone says try harder. Yeah, you can recover if you know what you're doing. If you have some memory that you can free, then maybe you can get out of a memory allocation error. Boston by Boston, I would agree that a defect should be irrecoverable, but my argument in my forum post was that if it's conversion to a range and you're not outside the base type's capacity, it should end it should be end an exception, not a defect. Yeah. I completely agree. I think that range defect should be a range error. There might be some technical reason that it isn't. But yeah. Kill some other random process and realloc. I'm not sure. I think at least on Linux, I mean, you could be limited in how much memory you're allowed to consume, I believe. So your process could have a limit. So it's not that the system ran out of memory, but you ran out of memory. Which would still cause memory allocation errors, even though you don't, or the system isn't out of memory. U limit, yeah. So you can't reliably kill another process and reallocate. Not that that's a very good strategy, anyways. But you could imagine some scenario where you have a large cache of something, and if you got a memory allocation error, you just like reset your cache and started again or something like that. So there are some scenarios where maybe you could recover. But yeah, that is Advent of Code, day 4, solved, in NIM. Yeah. Ooh, we didn't look at the image yet. Ooh, cool. So here we have the second floating island, or the island, as they called it. And I'm guessing this is the ocean or the lake on the island. And we are now going to borrow his boat and boat over here to an island on the island. A real like water island on the island. Yeah, that's pretty cool. I will try to be back again tomorrow, right about the same time. If you want to check out my solution, if you want to dig around and sort of try and tweak and fix and do things on it yourself, you can find all my code on my GitHub. I guess that might be too small for some of you guys to read. So let me just put it right there and not highlight it. There we go. So there you have my GitHub, where you can find these solutions. And there you also find a link to all the streams that are over on YouTube, because YouTube stores streams for me by default. Yeah. So if you would like to catch the next one tomorrow, then I guess subscribe or turn on some bells or notifications or something. I'm not a professional streamer, so I don't know what the terms are nowadays. Smash some bells, I guess. Yeah, that's everything for today, and hope to see you guys tomorrow. Oh, by the way, if you have any cool solutions from today or day 3, 2, or 1, you can ping me in any of the NIM channels, and I might take a look and show them off here tomorrow. Don't show me your cool solutions for tomorrow before tomorrow's stream, but if you have some cool solutions for today or the days before, then feel free to share them with me, and we can go through them. If you did something cool. Don't worry, they're all brute force loops. Yeah, I mean, it would be interesting. If you have a brute force loop solution, like I was doing for the other days, share it with me. We can contrast and compare the sort of naive brute force solution to something a bit more structured, something a bit, I don't know if it's any cleaner, but yeah. Oh, and just before I go, I will show you a larger example of NPEG. So this is my from my Notifi Shower tool. It's a small tool for X11 that creates notifications. It ended up being quite a complex thing. You provide it with a format string that specifies the layout, and you can set all of the background colors and images and 9-patch images, and you can attach actions, and you can attach hover actions. You can pipe stuff so it will live update your notification. It just blew out into a whole thing. It's actually pretty fun. I streamed the creation of this tool, so you can go and have a look at those streams if you want. But basically, all the inputs, all of these command line options, you can also put them in a configuration file format like this. These are the same options as above, and all of that goes into an MPEG parser, which parses everything out into this hierarchy of types, which is just basically from the one options object, it reaches all of those other types. And the MPEG parser is down here. As you can see, it's a pretty it has quite a bit of rules. It has quite a bit of logic. Like, if it encounters help, it just prints out the help and quits. Same for version. If it's a monitor, it figures out what the monitor should look like, and it parses all of this into this large options object, and the rest of the code just imports this module, runs parse command line or parse command file, gets out this large options object defined here, and everything from there on, it's just nym code. No dealing with any parsing after this step. Is it in Nix packages? If it is, I am not the one who put it there. It is in Nimble though. You can run just Nimble install Notifishower. I think you can. Yeah, you can. Nice. So yeah, it uses imlib2 and x11, so you need to have those installed. I actually haven't compiled this in a really long time. I'm not sure I ever compiled this for a pre 2.0 version. Seems to have compiled fine. Let's see. Yeah, that is the one we just installed. Seems to work. If we run this with, it has some defaults. So if I run title.text, no. Oh. Colon. No, space. There we go. It created a notification. If we say body.text, yeah, it has body. Yeah, this is the default format. It has an icon, a title, and a body. And you can, these are just regions, so I could say id dot text is hi, for example. Oh, that did not show up. Probably didn't have room for it. But yeah, if we had passed an icon in, icons are a file, I believe. Yeah, the layout format, everything is explained. Actually, this folder probably has. Yes, we have some images here, maybe. Let's try. Now I'm just playing around. That image. Notifisher.png. Didn't seem to work. I don't remember how to use this. It's been ages. Maybe I need an image of a certain size. Let's try this one. Nope. I have no idea what's going on there. Oh, wait, we have an examples folder. Here we go. That is IRC notifs. Conf. This background border 9 patch for that. Close action. Hard coded monitor. And some nim code. Ooh, quite a bit. Yeah, so this is back from the Freenode days. Right, so it just looks at my hex chat log, splits out. I think I actually used this for streaming. I used this when I was streaming, and it pulled out notifications from or all my mentions from I guess it pulled out all messages. This is commented out. It pulled out all messages from my Twitch chat, which, if you didn't know, is just an IRC room. So I can talk over here in my IRC chat window, and that just shows up as a Twitch message. So it's super easy to write bots and stuff for it. So yeah, it just looked at messages coming in there and called notifisher with arguments. Anyways, that got way off track. But yeah, that's a big example of using NPEG to parse quite a large grammar. Oh, actually, we didn't show off one of my favorite features of MPEG. The graphs. Oh my, the graphs. If we go back to AoC 2023 day 4, if we run compile part 2 or part 1, doesn't matter, it's the same parser, and define npeg graph. If we run this, look at this, it prints out railway diagrams for our parser. So here we can see that cards going to the card parser, goes to a new line, and then optionally goes back up to there or to the end. Card here matches the word card, repeating amount of spaces, then a number, which I'm guessing this is capture, goes on to a colon and a number list, and a pipe and a number list. A number list is spaces. Optional. so it can go around, but it can also loop through spaces. A number, and then all the way back. Ooh, so actually this would be a bug. It could match. Number would be consuming all the numbers. I was thinking it could repeat a number and go through here and not have them space separated. Yeah, these are super cool. It also has this dot graph thing. But yeah, it just makes it super easy to see what your parser is doing. Unrelated, you like my Mario scan set. Right. Your granddad was always wearing one. I think actually my mom knitted me this one. I think so. Are you Norwegian, since you know what it is and your granddad had one? Or is this something that immigrants from Norway took with them when they went to the States? Marcus on Matrix. Oh, I'm not on Matrix. I'm on IRC. So you might have a different name. Marcus Ramberg. Oh, okay. Yeah, I think yeah. I've seen you around. Right. You're from Oslo. Oh, cool. So, I mean, still probably closer to many of our European NIM users than to me up here in Tromsø. I think it's 2,500 kilometers away or something like that. It's quite far. Anyways, I need to get going. That's it for today. Check out Advent of Code if you haven't. Check out NIM if you haven't. Check out NPEG if you haven't. Yeah, it's cheaper to fly to Europe as well. Ugh. I'm looking at FOSDEM tickets. I think the most expensive part is flying to Oslo, which is a bit annoying. Yeah, that's it for today. Goodbye. Oh, you're going to FOSDEM. Cool. I'll see you there then. 1200 from Oslo on Friday. Yeah, I guess. I'll see if I can catch the same flight. Yeah. Anyways, that's it for today.